Okay, so here's a review video for section 5.3, inequalities in one triangle. They're really just two theorems, three, but really two of them are the same thing, just reversed. The first theorem is actually something we did a long time ago, but now it's an inequality version of it. We stated that on a triangle, the exterior angle of any triangle is always equal to the sum of the two non-adjacent interior angles. So if I add 54.33 plus 61.4, I get 115.73. And no matter how I move that, I always get that these two angles add up to this one. Well, the new theorem states that, okay, if those two add up to make the big one outside, then that means that the outside one has to be bigger than either of those two inside angles, which should make sense. If these two make up to this one here, this one has to be bigger than both of them. I know the difficulty in class has been the fact that some of you guys get mixed up with, well, isn't this outside one bigger than the one inside next to it that it's adjacent to? And the problem with that is it's sometimes bigger, but not always bigger. And here's a case where it's not. Right there. If I stretch this figure so that the outside angle is actually acute, that makes the inside angle next to it, the adjacent one, obtuse, making this angle smaller than this angle. But it's still bigger than the two non-adjacent interior angles. Now where that comes into play is a set of problems like this, where they're asking us to find the angles that measure more or less than another angle type. So for instance, angle 1 is an exterior angle, but it makes a triangle with these two angles here, makes a triangle with these angles here, and it makes a triangle with these angles here. So it makes these big giant triangles, three of them that overlap. So we know that 1 has to be bigger than 2 or 3, 4 or 5, or 7 or 9. Because those are the angles it makes a triangle with. 9 does the same thing but reverses it. Now 9 is 7 and 6, 4, and then 2 right there. Because again, it reverses the order of the triangles. 9 is an exterior angle for this triangle, it's an exterior angle for this triangle, and it's an exterior angle for this triangle. Now 5 is a little trickier because it's inside all the drawings. So I'm going to draw 5 like we need to visualize it. So it wants to know all the angles that are bigger than 5. Well, 5 is right here. And so it is the adjacent next to, or it's the, sorry, let me draw that over again. Here's angle 5 right here. So it is an interior angle remotely to angle 3 and angle 1, because those are the two exterior angles with respect to that. So it's angle 1, angle 3, and I should have put angle marks in front of all these, but I've been lazy. And now they're sloppily written in. You're welcome. And now for 8, it's the same thing, but now 8 is this angle here. So it has angle 5 as its exterior angle, has angle 3 as its exterior angle, and has angle 1 as its exterior angle. And if you haven't noticed, I've done a lot of these videos today, so I'm not really as neat as I once was like a couple hours ago. So I apologize. But 3, 5, and 1. So hopefully that's legible enough. If not, and it doesn't make sense, come in still, we'll sort it out. Now the next 6 problems here, we won't do all 6 of them, we'll just do a couple of them. All pertain to primarily one theorem left. But the book splits into 2, but it's really just one. So where is that drawing at? Right here. And that theorem is basically this. In a triangle, okay, any kind of triangle you want to make, the biggest angle is opposite the longest side. And that should make sense. If I keep opening this angle up more and more and more and more and more and don't try to change the other two too much as their sides are concerned, it just keeps making this guy bigger and bigger and bigger. Okay. And conversely, the smaller the opposite angle, the smaller the opposite side. Okay. So hopefully this is one, you can prove it, but it's I think just something that's pretty self-evident to see. That if you've got the bigger opposite side, which this one does right here, you have to have the bigger opposite angle. If you have the smaller opposite angle, you have the smaller opposite side. So let's take a look at those problems then. So for number 5, when it's giving the side length, it's straight, nice and easy. Don't worry about the ordering the sides. You should be able to order RP is the smallest, then PQ, and then RQ. But the smallest angle then is opposite the smallest side, which is the 2 side RP. The next smallest side is PQ at 5, so angle R is the next smallest side. And then the biggest side is the 6, which is opposite side, or opposite angle P. So angles Q and R and P are the order. For number 6, again, we don't have to worry about the angles because we'll have to find the missing angle. These two together are 122 degrees. So that means this is 58 degrees for angle M. So now my smallest angle is angle K, which means my smallest side is ML. My next smallest angle is angle M, which means my next smallest side is KL. And my largest angle is angle L, which means my largest side is MK. So smaller the opposite angle, smaller the opposite side. Bigger the opposite angle, bigger the opposite side. And it works both ways. So that's section 5.3.